Welcome to another webinar in the Iliad Hackathon webinar series. Today we are going to dive deep into one of the technologies, StreamHandler. So this will be a special webinar in that respect. My name is Bente Liljaby. I'm your host as usual, and I will of course also as usual start to introduce a little bit about the Iliad project. But today will mainly be about the StreamHandler. As we all know now, you should ask questions and comment in the chat, and we will give you the floor to discuss. And you might, I think, Evangelos, that we will give a possibility for people to ask in between. So you can raise your hand in between because you have several sessions of, the introduction to the StreamHandler. So this will be recorded, of course, as usual. And if you have some on the slides you have, Evangelos, will also be made available. And you will also find everything on the Iliad website, on the marketplace, eventually, shortly after. And this is meant to support, first and foremost now, the Iliad Hackathon participants, but it will also be available, of course, for everybody later. So I will start by introducing the webinar, the program, and a little bit about Iliad. So here we go. So today is the StreamHandler platform, ingesting and managing large streams of data. And we have divided it into several sections. First, you will get an introduction to Iliad for those of you who are maybe not so familiar with Iliad digital twins of the ocean. Then a general introduction to the StreamHandler platform, the capabilities, some examples in pilots, and then some more hands-on, I believe, Evangelos, on how to communicate with the platform, and yet more examples. And of course, a Q&A. So a digital twin, so the StreamHandler is now being used in the context of a digital twin of the ocean. And very briefly, a digital twin of the ocean is a virtual representation of the real ocean, which is composed of several components of water, of salinity, of sea level. I mean, there's a lot of different aspects of the ocean that we cover. And the twin will enable us to better see what now, understand what now, what next, and what if scenarios. In Iliad, we are also including historical data, so what happened in the past. And we are, of course, looking at the twins in the ocean that is composed of other components. So we have also economic data, statistics data, and data about the installations, etc. So all of this is a digital twin, very briefly. Iliad is building twins by enabling an ecosystem of interoperable digital twins, so multiple twins, and we are using existing resources, and we are also providing new sensor data, and the StreamHandler in this context is a very useful tool for integrating near real-time data from sensors in digital twins, and we also have a component of citizen science. All of the digital twins will be made available on the Iliad marketplace, so you can find it and be directed to the right place where you can access it. The marketplace is not only representing the twins, but also in various components that will be that you can use in other contexts, for instance, or building your own twin. And all of this is then supporting, addressing the societal challenges that we face. I will skip this. I mentioned that we have multiple twins. So we have thematic twins and we have local twins. And you see here the 12 different areas that is we are covering the categories. So it's ranging from oil spill to algae bloom to harbor management, etc. So there's a large variety of activity related to the ocean, and this is reflected in the Iliad digital twins. Here is an example, or here is the logical architecture of Iliad. And you see here on the left-hand side, the different data sources. And Evangelos will explain a little bit more how these, many different data sources can be streamed into the digital twin. The sensor data needs to be prepared so that it can be combined and then processed. So in the end, we will have various outputs, information and knowledge that will be visualized and that will be presented in a way that the users can use. So depending on depending on what kind of decision-making processes the individual user have. The twins, and just a few words of the reusability of different components of the twins. So each of these twins that I showed you in different thematic and local areas, they are interoperable, or components of them, depending, of course, you cannot put one twin directly into another area, etc. But components of it can be reused. So you see here that reusability of the components of Iliad digital twins are important, are facilitated. It's an Iliad. Iliad is a Green Deal Horizon 2020 project. It consists of around 56 partners. And it's a 3-year project, but we have just extended it, so it will end next year. So 1 more year to go of this project. It's in total, it's an innovation project. So in total, there are almost 20 million euros invested. With that, I will introduce now Evangelos, our expert on StreamHandler. He is working in Netcompany, our coordinator organization, and he knows all the bits and pieces. He's a software engineer, right, Evangelos? And we will just dive into the StreamHandler now. The floor is yours, Evangelos.
Yes, hello all. Thank you, Bente, for the warm welcome. I'm Evangelos Agorogiannis from Netcompany. I'm part of Iliad project the past 16 months around. And in our case, we're working as the coordinators of the project and the work package for leaders, where we're offering the major part of the technical components of the project. Let me share my screen. Today we will discuss about StreamHandler platform, which is the main tool that we're offering. So please inform me if you can see my screen, and we can proceed.
We see it, Evangelos, go ahead.
Oh, okay, nice. So let's start with the agenda. As Bente mentioned, we are having an overview of the platform, some of the capabilities of the platform within the project, how the platform is used in Iliad, and in the final part, we're having some examples along with the ways to communicate with our platform for the data interaction and data exchange. So let's move on to the StreamHandler platform overview. This platform is developed by Netcompany Intrasoft. It is a distributed streaming platform that helps the handling of messages real time. And it is based on Apache Kafka and microservices. The platform is used to ingest large amount of data into processing pipelines for real-time and batch processing. Some of its key capabilities and features that offered through the platform is the real-time monitoring, the event processing, the alert notifications, the interoperability that it offers with the modern data storage and technologies, and multiple data sources that are used in the IoT world. It is a distributed messaging system and this federation that it offers, it's something that we are interested also in Iliad, and it is a platform with high fault tolerance, resiliency, in order to support some automatic recoveries and be available and running without any problem. It offers also high scalability. It's something that we are really interested in, since we are discussing with, let's say, for large amount of data, and we have many data both in Iliad and in other activities that we are using the platform. And also the platform offers security with encryption of the data, authentication and authorization of the users to ensure data integrity and security, and let's say secure data exchange among the platform. Now, moving on to the platform architecture, we are discussing about a platform that is consisted of multiple layers and multiple modules that are, let's say, operate all together to support the functionalities of the platform towards the data ingestion by interfacing external data sources and systems, also for the handling and the processing of the incoming data streams, and of course the knowledge extraction and visualization of the information, since everyone knows that this is a really important part during our technology time. So the overall design of the platform, it has 3 high-level layers. We are having the analytics, starting from bottom to down. We have the analytics and visualization layer, the messaging and storage core, and the integration layer. And of course, we're having the data sources from which we are gathering our data. So for our platform, we will start from the integration layer, which lies between the data sources and the core part of the platform. And it is the layer that facilitates the seamless data flow and interoperability between the different systems, and ensures that all the data are ingested properly, can be processed, and can be queried efficiently. As you can see, there are several modules that consist this layer, and multiple interfaces that support this interaction between the Apache Kafka cluster that we are having and the storage supported with the external data sources. So we will start with the Kafka Connect cluster, you can see here, which is responsible for the integration of the Kafka with external systems, like the MQTT cluster, for example. In our case, in Iliad, we are interfacing actually with the MQTT broker, where we're gathering data from the sensors that are installed in several pilots. And let's say this layer connects and transfers the data from this MQTT cluster through the MQTT Connect to the Kafka cluster. We're having also the Kafka Client API, which is responsible for applications and can be used for applications that they want to interact directly to the Kafka cluster, either producing or consuming messages. We're having the Kafka Streams API, which is for real-time processing and stream processing capabilities, and also transformations on the streaming data. We're supporting also a KSQLDB, as you can see here, which allows stream processing using SQL-like queries. We're having, of course, a REST proxy, which provides HTTP and HTTPS interface to Kafka in order to facilitate the integration for the web-based applications. And let's say you can see here that we're having some producer and consumers clients that are using RESTful interfaces, and we're having also the database APIs, which are the APIs offered by the storage and the different databases that we support in order to access and query all the data that are stored within the platform. And this is, let's say, the overall picture of the integration layer, connecting the data sources with the main core. Moving on, we are having the StreamHandler messaging and storage core layer. You can see that this layer is also consisted of multiple modules. It is the main pillar of the platform, since it ensures the reliability for the data transmission, the storage, and the retrieval. And the modules that consist this layer are the Apache Kafka cluster, and this module includes the Kafka brokers, where the data are published and handled all the data streams, and also it keeps the message log storage. We have also within the Kafka cluster the Zookeeper cluster, which includes the Zookeeper nodes, and this cluster is responsible for managing the state, the cluster, performing some Kafka related actions like the leader election, the replication of the data, and this, let's say, cluster ensures the high availability and reliability that the platform ensures. Also, we're having a schema registry, which supports Avro schema, JSON schema, protobuf schema, and this schema registry module is for managing the format and the structure of the data transmitted through the Kafka topics, and let's say it maintains the data consistency and the compatibility. And finally, we're having the storage and database modules, which are used for storing the data transmitted through the Kafka topics in order to be available for efficient retrieval and querying, for backup purposes, for historical purposes, and it can support several types of databases like relational databases, NoSQL, and time series. Moving on, we're going to the top part, which is the analytics and visualization layer. As you can see, this layer has two main parts: the data analytics part, which is related to the data processing and knowledge extraction capabilities based on the incoming data, and the other part, which is the UI and monitoring and all the visualizations that are used for presenting the data that are ingested in the platform, and also this part supports the monitoring of the overall system and the administration. Let's say, because we want to be more specific, we will dive into the data analytics part, which you can see here. We're having several components that are supported, and we are having, and this data analytics part, it offers functionalities for transforming the raw data into valuable insights and recommendations. It incorporates several components for this strategic planning, this optimization that we expect. It enhances the decision making, which is an important factor when we're having a large amount of data coming in the system. And we will focus a little bit on what is used in Iliad. We are having this warning system, which is a tool that is used for timely detection of abnormal conditions according to some predefined values and thresholds and rules that are defined by the ocean experts that we are collaborating with the project in order to, let's say, define those limitations for the measured values, and provide this enhanced awareness and the warning and the notification system in order to check what is going on with some specific sensors, some specific locations, and what and they have a better overview of the process. Also, some other capabilities that the platform supports, but have not used up to this point in Iliad, is the recommendation system in order to provide some recommendations based on AI and ML algorithms and some data analytics methodologies. We have also the decision support system that supports the decision-making process, and it integrates various data from multiple sources and applies some analytical models. We have some metrics aggregations for gathering and transforming the incoming data to, let's say, a common format for further analysis. And we're having also some KPIs calculations in order to help the computations and calculations of the KPIs that are related to the project objectives and other metrics. Regarding the user interface and the monitoring and the visualization functionality that the overall platform supports, we have the admin panel, which is used, which offers an interface for the administrator of the platform to manage and configure the system, check the user management, the settings of the system, the access controls. This panel is for the usage of the administrators of the system, in this case, in our team. We have the data monitoring, where there is a continuously monitoring of the data streams, the system performance, and there are some, let's say, information and real-time notifications if any issues are identified within the system and any problems. And we have, of course, some custom dashboards that can be created in order to visualize the data, display some use case specific information, and provide, let's say, those insights and overview of the platform. Those are the information about the core system of the StreamHandler. I don't know if there are any questions up to this point, or we can proceed.
Yeah, if there are any questions, please raise your hand, and or write in the chat. I don't see anything.
Sure. Okay. For sure. If there's something in the chat, please inform me, because I have minimize the.
Yeah. No, I will monitor that.
The window.
Okay. Yes.
Nice.
No, don't worry.
Thank you.
So far, but do ask questions. There was a lot of detailed information,
Exactly.
even at this stage, Evangelos. So don't be afraid to ask questions. And if you, I mean, I would actually, in this case, in this particular webinar, I think maybe you could raise your hand, because I'm looking at the participants at you now. So if you raise your hand, I will observe it, and I will interrupt you, Evangelos.
Nice.
Yes. Okay.
So
go on.
So let's proceed. Nice. As discussed already, we have presented all the layers of the platform, and now we're going to focus a little bit on the capabilities of the platform and how it is used in Iliad. This platform, our StreamHandler platform, it uses for the communication the TCP protocol, and the representation of the messages is in JSON format, a common format for common representation of the data, which is easily readable and understood from everyone. We have performed an alignment and compatibility with the Ocean Information Model, which is the main model for the data representation designed within Iliad and offered by other colleagues from the project and other partners. From the main part that we described earlier, we're having the messaging and storage core. We have the connection to the Mongo database in order to store all the transmitted data for backup and historical purposes, and to be accessible from external sources and other tools by connecting to this database, which is also part of the messaging core. We're having the interoperability integration with the MQTT brokers that are offered by Taltech, the partners from Estonia that provide the sensors that are deployed in the Iliad pilots. And this interoperability and integration, as mentioned earlier, is performed through the integration layer with the Kafka Connect cluster and the MQTT Connect in order to access the MQTT brokers. We're supporting secure and encrypted communication between all the brokers and the clients, and between the MQTT brokers and the Kafka brokers to ensure that all the data will be transmitted in a safe way, only to authorized and authenticated users. And also, we're supporting the alerting and warning mechanisms that are part of the analytics layer. And we have implemented this rule-based processing system that offers the functionalities of alert detection and notification on the data streams and the values recorded from the sensors that are deployed in the pilots. And also, we're having the user interface and monitoring capabilities to have the overview and supervise the performance of the platform and the exchange data. So, moving on, we're having, let's say, this Iliad architecture, what also Bente presented earlier. As you can see, our StreamHandler is here in the data provider part, supporting the distributed data streams, and it ingests several data sources from the data source layer, performs, let's say, any transformation that is needed, performs this knowledge extraction with the alerting mechanism, and share the result to the digital twins and the front end, where we're having the visualization of those alerts that are mainly created from our system. And this is the role of the tool in the project. Moving on, we're having the tool that is involved, and the pilot that the tool is involved in Iliad. There are 5 pilots that are using our tool. Our tool is working in collaboration with the sensors deployed by Taltech, as mentioned earlier. And we're having this integration between MQTT and Kafka brokers to gather and transmit all the sensor data to the Iliad DTOs. Let's say our platform is a data platform, gathering data and serving the data, integrating the data for the Iliad DTOs to be available for further processing and knowledge extraction. And let's say this setup, as mentioned, provides all the information for those alerting processes that we have described. Our tool is used specific on the oil spills pilot in Heraklion, in the ship routing pilot in Heraklion, the harbor safety in Varna, in the aquaculture in Italy, and the coastal sediment transport in Estonia. Also, you can see some of the data samples that we are using for the data that we are receiving. Those are the data we're receiving from the sensors, a sample of the data that we're receiving in JSON format. This is the process that we're performing, and we're getting this format, and those are the alerts that we're creating for this knowledge extraction according to the data that we have received. Those were also the details about our tool and how it is applied in the project, how it is being built. And in the next part, we're having, let's say, some guidelines and some instructions on how the rest of the components can communicate with our platform. And we have included also several examples for better understanding and to help the participants to comprehend better on how they can integrate with the platform. And I think that this is a main part of this webinar and the series of the hackathon, since this platform is already implemented and deployed. And through this series, we expect that the hackathon participants will be able to communicate and exchange information. So I don't know if there are any questions, or we can proceed to the next part. I don't know.
I don't see any raised hand. Now is your time. If you have been burning with the question, please raise your hand or write in the chat. Meanwhile, Evangelos, I posted some more information about the StreamHandler that you have provided for the Iliad marketplace, where, as I said, everything will be made available via the marketplace in the future. And currently you can read some of the information about the StreamHandler there. And I was about to also to share some information about the hackathon. By the way, if you are, particularly if you are an Iliad partner here and you see that, oh, this StreamHandler is perfect, it's not too late to actually dive into using it by being a participant in the Iliad hackathon. We are still recruiting. The 8th of July today, so we are just about, the teams are forming right now, so you will be given a place if you are interested in finding that, okay, this StreamHandler is perfect, I want to play with it. Just saying.
Sure. Thank you. Yeah. Thank you, Bente, for mentioning this. Of course, it is really important for all the participants to understand the purpose of the tool, how it operates, and the main part is here how to communicate with the platform. That's why we want to focus on this part for the following minutes until the end of the session. So probably we will see also some questions up to this point. And of course, as Mende mentioned, all the details will be uploaded in the marketplace too, for everyone to access all the details. So as discussed earlier, the platform supports through its integration layer multiple interfaces to interact with the overall platform and the overall cluster of the platform. So we will check with some useful examples and insightful examples this integration, how it can happen, and how the participants of the hackathon can use the platform, what are the implementations that they can perform to access data, ingest data, exchange data, and all those operations. So starting with the Kafka Connect, we will explain some more details. We're having three main parts for the Kafka Connect: the connectors, the workers, and the tasks. This that is most important, let's say, for the participants are the connectors, because we are having the modules that the connectors are easily configured modules that facilitate this data transferring between the Kafka cluster and other systems like databases, IoT platform, as already discussed. And we are having two types of connectors: the source connectors that are that the purpose of the source connectors is to pull data from external systems into the Kafka topics. So, for example, you can define a source connector that gathers data from your system and publish those data into our platform. And we're having also the sync connectors, where the data from the Kafka topics are consumed to an external system. And also for your part, during the hackathon, you can configure some sync connectors and consume data directly from the topics to an external system. For the workers and the tasks are some, let's say, embedded processes that execute the connectors. The tasks are the units that execute in a parallel processing format the different works that have to be implemented and performed. So we're focusing, as mentioned, in the connectors part, the source connectors and the sync connectors. That's why we're having some examples in order to demonstrate how this takes place. You can see that we're having a MySQL connector here, for example, which acts as a source connector. And you need just a configuration file in order to define a MySQL source connector. And as mentioned, the source connectors are used. So, for example, we're having a MySQL database, some specific tables that can be used and can act as a data source of the system and publish the data from the tables directly into the Kafka topics that you're going to define. And you can see the configurations here. We're having, of course, the name of the connector. We're having here the fully qualified class name of the connector that should be defined in order to identify which sensor, which connector will be used from the Confluent available platform. We're having this tasks max configuration, which defines the maximum number of the tasks that should be created from this connector. We're having, of course, the connection details in order to communicate with the database. This table.whitelist defines which tables will be included. The mode is the operation of the connector regarding the timestamp, the incrementing, etc. The column name here defines when we're detecting new rows, how the messages will be published. And the topic prefix is the prefix that is added in the Kafka topics to which the data will be published. Also, we're having another type of, let's say, perform this configuration. We're having JSON files. Here we're having an example of an MQTT source connector example in JSON file format. Similarly, we can define an MQTT broker acting as a source, publishing the data, and this Kafka Connect can directly ingest the data from the MQTT to the Kafka brokers. So similarly, we're having the name here to define the connector. We're having the class which is used for the connector, the tasks. We're having the address of the MQTT broker to connect. Here we're having the topics from the MQTT where the connect will be subscribed to, and the topic where the data from the MQTT will transfer to Kafka. And for example, here the data on my MQTT topic will be written to my Kafka topic. We're having some other configurations related to the MQTT, and of course the credentials for connecting to the broker, since in most cases we're using some password authentication. And something that is really important is the value converter, let's say, field, which defines the class that we are using for converting the payload of the message in order to translate and serialize properly the message. Those were the examples from the source connectors. We're having also an example in JSON format for a sync connector. a MongoDB sync connector and as mentioned, the sync connectors are used to consume the data from the topics and ingest them to an external system. In this case, we're presenting a MongoDB where the data are consumed from this topic and are stored in this database and more specifically in this collection. There are specific configurations for each type of source and sync connector that can be found on Confluent platform. We're presenting you some of those that are most important in order to be able to exchange and consume the data. As you can see also for MongoDB, we're having the address of the database, and as mentioned here, the database where the data will be written in the collection. And of course, we're having the key and value converters which define the converter class for converting the message. And of course, this value converter schema enable defines if we should include a specific schema in our database and the data format. Regarding the Kafka Connect interface and how it can be used, those were the parts that we would like to present. I don't know if you have any questions or we can proceed to the next part.
I still don't see any questions and hands raised, but maybe we should give them, we can give the participants a little time to think about it. And then meanwhile, while they are thinking, I can share the results of a small little poll that I posted while you were speaking, Evangelos. And I simply asked, do you use or need real-time data? And you say that you see here that yes, it is an integral part of my service application. So you have a crew here, somebody who needs that. Yes, simple yes. Or somebody who, and we also have some who want to, but are not using it. And then you have some who won't. But just to give you all a little sense of who we are here as a group. And do I see any hands while I was sharing that? Nah.
No. Nice,
it's a
but
lot
I see that
digest. Yeah.
I see that it's important that we have many participants that are interested and they see that the platform fits to their solution.
Absolutely. Yes. Okay. Go ahead, and then we will see if the Q&A session will we will be able to tease out some more questions.
Yeah, sure. Nice. So let's proceed with the next, let's say, available way to communicate with the platform. The Kafka Client API, which includes the producer and the consumer APIs, and those are provided by the Apache Kafka and allows direct communication with the Kafka cluster. The producer's API is used to publish data to one or more topics and include some configuration options for their operation and behavior. And we're having also the consumer API, which performs the corresponding consuming operation by subscribing to topics, reading and process the incoming data. And it has also some configurations for the operation and the behavior of the consumer. Kafka client libraries are available in multiple programming languages, like Java, Python, C++, Go, and Node.js. And today we're having an example of a producer client in Python. You can see that it is a short, it is only a few lines of code in order to access and communicate with the Kafka cluster. So you can see that here we have those configurations in order to define the address of the broker here with this Bootstrap servers variable, and we define where is the broker in order to communicate. And we're having also another configuration, which is the value serializer, and this serializes the message in JSON format. It is really important to note here that the messages in Kafka are sent in a byte array format. So we're using serializers in order to convert the messages into other format that is familiar, or let's say better fits with our case. In this case, we're having JSON format, but there are other serializers like the string serializer, the byte array, the Avro serializer, and also the users can create their own serializers if some of the already implemented don't fit in their case. So you can see here the configurations in order to connect and configure the producer. And here we're having the producing part where we define the topic where the message will be published. Here we define a message that just has a number. It's not something similar, and it's not something else. It's just a sample of the usage of the producer. And of course, in the end, we are using this producer.flash in order to ensure that all data have been published before closing the producer. Moving on, we're having the consumer client in Python. Here we have similarly some properties in order to configure the producer. We are having the topic, which defines where the in which topic the consumer will be subscribed to consume messages. We're having also the Bootstrap servers for the address of the Kafka broker. We're having another configuration, which is the auto offset reset. This configuration controls the behavior of the consumer. It has two values, earliest and latest, and this the default value, if you don't let's say add this configuration, is the latest. And this configuration defines the strategy that the consumer will follow when is connected to the topic. The earliest configuration makes the consumer to consume the data from the beginning, from the initial message that has been published in the topic. And the latest configuration defines that the consumer will consume data after the consumer's let's say starting. We have also the group ID, which defines the consumer group to consume, and we have also a similar configuration to the previous one with the producers. We're having the value deserializer, which is used to deserialize the message. And as mentioned earlier, that the messages are published in a byte array format, we use those deserializers to convert the messages to a format that is familiar to us, like the JSON format that we're using here. And there are also other deserializers like the string deserializer, the Avro, etc. And of course, you can also create your own deserializer. And those were the examples for this part. The Kafka client APIs. If we don't have no questions, we can proceed to the Kafka Streams API.
Yeah, it looks like it. Well, questions, in the chat. And
okay.
You have one? There was one?
Yeah.
Yeah, Bobby. Yeah.
Yes.
Quick question for you. Can we utilize the StreamHandler in all types of data, or do we need our sensors data, or how we can utilize
Yeah, The platform and in general the overall let's say StreamHandler can be used in multiple types of data. It's not something that we want to limit. For example, to the sensors data, we can consume multiple types of data because the platform is also the Kafka on how it operates its data agnostic. We just let's say provide some guidelines of some data that are more easily to be used, like the JSON format, for example, or XML or something else. We can send CSV files. We can CSV data. Excuse me, no files. The only, let's say, limitation that the Kafka has is that the optimal performance is for data that their size is around 1 megabyte. So if we're having larger data, we have to somehow pre-process them and split them into batches to achieve, let's say, the best performance. Of course, this size is also configurable. It can be updated by, for example, sending larger messages, but we try to keep the optimal configuration on sending data. But of course, we can support multiple types of data, and that's why we are offering also this integration layer with the multiple modules in order to be able to be interoperable and to integrate multiple data sources, multiple types of data, independent to their format, their size, and let's say this integration layer performs the necessary transformations to ingest the data to the platform.
Can I have a follow-up question?
Sure.
Thank you, Bobis. That was a good question. I'm wondering if when you are saying you are ingesting from different data sources, some of the sensors, so let's say you have different sensors, different types of sensors. How do you harmonize? I mean, the timing, the reference frames of these data, how does that come into, how do you handle that? Because it could be, even the timing, we have a discussion, even the timing of the data can be tricky too.
Yeah, that's true. We're trying to apply zoned times for the timestamp, let's say, of its values. So we're keeping this common representation of the timings to avoid inconsistencies and misunderstandings. We are consuming both the raw data, but we are also perform some transformations to harmonize the data, let's say, and offer and add some attributes, some fields that are important for our processing part. And let's say we're trying to, because some data coming from the sensors directly are not in a understandable format, let's say, and we're trying to transform them to be more easily understood by everyone.
Yes, and then you have, so when you, yet another question
Sure.
on the near real time. So near real time can be many different times because depending on the instrument. So going from, so do you handle everything from near real time GNSS data to, so in some places near real time is also once a day, once a week, the near real time.
No, it's near real time. We're discussing only for some, let's say, seconds or milliseconds part. At least for the at the point that we're here and the data that we're handling in Iliad. For example, what we discussed about the warning mechanisms. Let's say we display both timestamps, for example, when the measurement come and when the notification is detected. And you can see that the difference is only a few milliseconds or seconds, depending on the let's say, if there are any issues on the connectivity, because also the sensors might have interruptions on their own. It's not because, you know, being on the open field, this can cause some delays. But yeah, this is the near real time that we're supporting. And of course, we're having, let's say, compact data formats and small messages, which is a good, let's say, part on this near real time support. Thank you for your questions. So let's proceed a little bit because we have limited time. We have to check some more cases. We have the Kafka Streams API in order to integrate with the platform through the integration layer, which is a client library provided by Apache Kafka and can act as a stream processor. It has two key concepts: the K-streams that represent the stream of the records, and its record is written as an independent event, and those Kafka streams can consume as input streams some topics, perform some transformations, and then send the results to an output stream to one or other multiple topics. Here we're having an application that uses the Kafka Streams API to read from an input topic and try to transform data to an output topic. You can see here that we have this application is implemented in Java. You can see that we are having here the similar part of the properties and the configurations of the application in order to configure the Kafka broker address, to configure also the topic for reading the stream. You can see here, for example, we're having this input data topic where this consists the input for the stream that we're creating. And here we're having the main part where the transformation of the input data is performed. For example, here we're having a temperature that is written in Celsius, and it is transformed to Fahrenheit, and this is the output stream that we're creating, and it is published to this output topic. So we're having those steps by defining the broker address, defining the input stream, defining the transformation process, and then defining the output stream. Moving on, we're going to another case that can be used to interact with the platform and the data. We're having KSQLDB, and this is, let's say, more familiar to the SQL fans because it is an event streaming database that is used for streaming processing. It, let's say, offers and supports complex transformations, real-time of the data streaming through Kafka using SQL-like query language. And you can perform queries to transform, aggregate, and read the data real-time on the Kafka topics. We have the SQL-like interface, which use SQL syntax to define those processes. We're having also streams and tables, which are the data that define the streams for the different operations. And of course, it can support stateful processing for supporting to support joins, aggregations over the data, etc. We're having an example here of an application which reads some data as an input from a Kafka topic. Here, for example, you see that it reads some sensor data with the timestamp, the temperature, the humidity, the carbon dioxide. This part defines the input stream. You can see that the input topic is defined here, and also we define the format of the data, which is a JSON format. So we provide all the details in an SQL like query. Then that we have defined the input, we're going to the data aggregation part. Here that let's say we're creating a table that calculates average values for a 5-minute sampling window for the measurements that are gathered. And then we're having the result stream, which gathers the data from the aggregated table and selects the results that we want and creates the output stream and writes all the aggregate data in a JSON format, also defined here, to the output topic that is also defined. So that's also another way to easily interact with the Kafka and the platform. And let's proceed to the final, let's say, way that we can support for communication. We're having the REST proxy, which is a RESTful interface that is provided by Confluent, and through this, the developers can interact with the Apache Kafka cluster using HTTP and HTTPS requests. And this is something really important because there are some languages that do not support Kafka clients. So through this REST proxy and this interface, we can have an easy way to produce and consume messages, manage topics, perform administrative operations, etc. We would like to focus on the producing and consuming part, let's say, which allows the applications to send and receive data from the topics using the HTTP requests. We're having also the schema registry integration to, let's say, by supporting some specific schemas like the Avro, the JSON schema, and the protobuf. We have, of course, the topic management, which provides endpoints to, let's say, list, create, and delete Kafka topics, and also the consumer groups that supports the creation and managing of the consumers that will be created. You can see those operations on the upcoming example, where we're having this scenario of a web application that produces and consumes data using this Kafka REST proxy. We're having this post method, which let's say defines a message structure. Here, the records that we're publishing, it defines the topic that the data will be published, and by performing this operation, the data will be published to the corresponding Kafka topic. Then we're having another operation through a post method where we create a consumer instance. Here you can see the consumer instance that is created and the group that it also belongs. We define also the format of the messages that is expected and the behavior of the consumer that, let's say, will consume the data from the earliest or latest offset as we discussed earlier. Also, here we're having, let's say, a part of the created consumer which subscribes to the input data topic. And since it is subscribed to this topic, we expect that this consumer will receive and read the data written into this topic. And we have also the consumer, let's say, action, which is performed through a GET request, where the data of this specific created consumer, this data consumer instance that belongs into the data consumer group, will consume the data and receive the data from the input data topic into the JSON format as defined earlier. So this is also an easy way just with using some HTTP requests in order to interact with the Kafka cluster. So this was from our side. And now let's say we're going to a Q&A session. If you have any questions that you would like to ask, any clarifications that you need, if you find something that needs further clarification. So I see a hand raised from.
Yes, can you unshare your screen also, Evangelos?
Yeah,
thank you very much.
Yeah,
I'm
Kaori.
Kaori.
just
Yeah.
a second,
Yeah.
please.
Yeah, thank you, Evangelos. So I have
Yes.
some questions. So first I wanted to see what your platform does. So, and then comparing to this design of the architecture of the Iliad. So I wanted to ask about metadata. Sorry, I came in late, so you might have mentioned it at the beginning, but after data ingestion and coming from this your data streams, do you produce metadata as well? I mean, it has this data flow of metadata in the diagram. But...
Currently, we don't have a specific metadata, let's say, handling or creation because it was not requested. For the handling of the metadata, there is another task that, let's say, performs relevant activities, but it's something that, of course, we can support.
What do you mean? I mean, because you are talking about the StreamHandler, right, Kaori?
Yes.
Yeah,
Yes,
but
yes.
I
So,
see in the architecture design has a metadata flow from your data streams to data catalog or service catalog. Yeah. So that I thought that maybe you have already harmonized metadata formats or.
yeah, so we heard earlier today about the wavy drifters, that they are collecting data and then shipped the metadata later. I mean, some basic data like timestamps and coordinates are following the data, right? In any way. But then additional metadata is then connected after the StreamHandler then?
After the StreamHandler, yeah.
Oh, I see. Okay, yeah. Okay, I see. And then another question would be, by the way, thank you for all the examples in detail. So your platform has this, the analytics and tools. So I was wondering, what about the output from the analytics engines? And then, do you have any function to publish or somehow, users can save somewhere like in Iliad data space? I don't know how that, I mean, that's part of your task, or maybe, Bente might have an answer to that.
Let's say this is not part of our task because in Iliad we offer only a specific operation from the data analytics part, only the warning system. And we have discussed on, let's say, visualizing this this output, the results from the warning system to the Work Package 6 visualizations for the pilots that are using our tools. So in this part of the project, we don't offer a specific, let's say, visualization, but we're offering our results to be visualized to other platforms and the specific digital twins, and the data are accessible through the Apache Kafka because the warnings are also published to the messaging core.
I see.
Okay, so for me to understand, because we are we are a federated system of systems. So those who are collecting the data from the sensors, going through the StreamHandler to somewhere, right? To a repository somewhere. And the repositories can be on your PC, or it could be to, for instance, Copernicus. I think even directly to Copernicus, or maybe a stage in between for quality check or harmonization. But in principle, Kaori, the idea is that the data can be streamed then to various repositories. And
okay.
yeah, so but you have a very good point in, for some data can go directly if you know the sensors and you have all the formats and everything in place beforehand. It can go directly to a data lake, or if you want to manage the access, the authorization, etc., it could be put on a data space, if so, or just a plain good old-fashioned data repository. It could be MODNet, the different thematic. And I think this is, if you look at
some options I see. Yeah, it's just that in the architecture I saw like different components components have its own data store, but
yes,
like ocean data space, and the first diagram that that was shown, and then Iliad digital twin, and then so that's why I see that probably you have some options. Exactly that one.
So you see, so we do we have different options. Yes, so we have data coming in here from the left-hand side, and then data store. You see here, this is ocean data space we are planning. This is one example, but then you have other data stores, and then you do the modeling and analytics and further semantic harmonization. I mean, you have semantic harmonization in several places here. You see, in several along the value chain.
Right. So maybe this is the last question. Are you planning to support various types of metadata? Because I see many metadata attached to the components.
Yeah, it's a good question.
Do you mean overall in the project?
Overall Iliad,
Oh, yeah.
Well, at least your part,
overall in the project, there are discussions on trying to establish a specific format for the metadata to have a common understanding and a common representation, and to be compatible, to all the initiatives that are underway. So it's under discussion to define, let's say, this common representation for the metadata and how everything will be handled. Because since we're having many pilots, we're having many components, it is the better case to identify a common approach and the overall model, and those are the activities performed under some specific tasks, like the ocean information model, the vocabularies, and the APIs that are offered in order to, let's say, reach to a common approach.
Yes, I see it very complex. From that diagram.
But Kaori, I think also the ocean information model comes into play here. I mean, where we are, I mean, that's part of the harmonization that we defined an ocean information model that is divided into different layers. So some of them will be very similar. And then you have more thematic specific types, the information models. And then eventually we are also very pilot individual twins specific vocabularies.
I see.
So we are working on that, and that's work that's being done with the leadership actually of OGC. And so we are bringing the work that we are doing here in Iliad based on all the different twins, right? We have so many different thematic twins and local twins. So we are sort of a very good laboratory for developing this ocean information model. And then this is brought to the standardization bodies, global standardization bodies. So we are collectively as a community developing this ocean information model.
And also, just to add to this, because we're having also a task under the project, which will perform the data cataloging for the pilots, Next.geo's platform, where we expect, let's say, to gather the data and the model outputs and their metadata in a common, let's say, repository.
Yeah, I was going to find, I actually think we have the ocean information model as a webinar already, Kaori, because I think maybe this is interesting generally for you and for others also. And then I don't find it, of course, when I'm looking at it. It's not yet here on the. I will find the link to that. We have had a couple of webinars on the ocean information model already. So if you go to the YouTube channel, you will definitely. I know that some of them are there already.
Okay, I will find it. Yep.
Yeah.
Yeah. Thank you so much, and for a lot of information. Very useful. Yes.
Thank you very much for your questions.
Are there any other questions and comments? So this material, of course, is a lot to digest, Evangelos. We have to.
For sure, for sure.
Yeah, I do have a question that might be interesting to have recorded also, is what kind of skills is necessary in order to be able to make use of the StreamHandler?
Let's say, as you can see with the integration platform and the integration layer that we have added, we're trying to cover multiple, let's say, engineer skill set. Let's say offering for people that are more familiar with the streaming technologies to add the K-streams APIs. With people that are more related and more familiar to databases, SQL-like query, we have the KSQLDB. Also for software engineers using the client APIs, it's an easy way to integrate in multiple languages, Java, Python, C++. We don't want to limit the participants and, let's say, the clients that are consuming and publishing data to the platform. We're trying to open this as much as possible. So, you know, just having some, let's say, skills on coding.
Yeah, some skills,
it's not
basic.
Yeah.
Yeah. And in either one of the, so you should look, if you are a coder of some sort, you should look if you recognize some of the tools that you have mentioned. But then it looked like you have to know more than one in order to be setting up the StreamHandler, right? It's not sufficient to just, I mean, if you look at the first slide you had,
Yes,
Evangelos.
Yes.
Because I think that's where you can identify what kind of skills in the combination.
Just a second, please. Do you mean this slide?
Yes.
Because yes. We're interested, let's say, to offer as much as possible solutions in this part, this integration layer, which, let's say, can be somehow the interaction will take place through this, because, let's say, the messaging and core and storage core are already fixed, let's say, from our side. The analytics and visualization are also fixed from our side in some cases. Of course, if anyone wants to gather the data to visualize them, it's easy to, but they will offer another visualization, not a part of our platform. Also for participants that are not familiar in, let's say, the streaming and the event-driven architectures, they can use directly the REST proxy. They can use directly some of the other APIs. It's not a problem. Let's say it would be good it is a nice to have, let's say, a familiarization on the event-driven architectures and microservices technologies. But it's not, let's say, a huge requirement. Let's say this is the part that, let's say, it is an important qualification for the participants is to know some stuff on coding.
Yeah, okay.
In order to implement the corresponding clients.
Then they will be able to consume to learn what they are missing, because they have that's what I was after, for people to estimate, you know, what exactly, well, not exactly, what approximately is needed to be able to make use of this.
It's
and
important.
if you say you have a sensor and you want to use the StreamHandler, or maybe a couple of different sensors, and you want to use the StreamHandler, can you give us with with some skills, coding skills, some time estimate of, how much time is required to be setting up the StreamHandler?
Not setting up the StreamHandler, just communicate with the StreamHandler.
This is to make use of the StreamHandler.
Make use of the let's say if you're having one sensor, you have to define the protocol where you have to create a client publishing the data to the specific Kafka cluster of the StreamHandler. So, it can be for someone experienced, it can be a work of a couple of hours. For some that is not experienced, it can be 2 or 3 days. But it's not, let's say, so difficult. Just interfacing
with the StreamHandler.
The StreamHandler, because we're trying to make it easy with all those, let's say, options and different interfaces.
Right.
So, everyone can find which fits better to the knowledge and apply it easier.
Yes. I just wanted to cover that because it was a lot to take in one go. But then, of course, this is also going to be made available on the website, and we will do time coding stamps also on the different parts of your presentation, so you can jump back and forth from the various aspects that you covered, Evangelos. So we will try to make this as easy to consume as possible. And you have also some written guidelines, I believe. You also have some material that follows this.
We have some material. We have some material, mainly with the for the examples.
Yes.
Mainly for the examples. And of course, we're having some other presentations for the platform.
Right. So all in all, this can be, all in all, very nice. And thank you for a very detailed, this is very useful, Evangelos. And this is what is needed actually for people to be able to start to use it. So this is very good. I don't see, thank you, Kauri. Thank you for joining and sitting with us for such a long time. And that goes for the rest of you that is still in the room. On Friday, we will actually go to the sensor part of this value chain, and we will have a webinar on different sensors in the Iliad pilots, twins, and we will you will get an overview of the sensors, and we will dive deeper into some drifters, the wavy drifters. So that will be on Friday this week at 12 o'clock. So do follow us on social media, follow us on the website, and register for that webinar as well. And with that, I bid you very goodbye. Thank you so much. Thank you.
Thank you very much. Thank you very much for your time and the interesting discussion. Thank you. Bye-bye.
I will stop the recording.